So, Boyle's law. Basically, a scientist figured out there was a relationship between pressure and volume when it came to gases. This is the relationship. Or if you want, you could think of it as being basically pressure times volume has to be a constant. For a given gas at a constant temperature, constant means it's not going to change, at a constant temperature, basically, if I change one of these, the other one has to change in such a way that when I multiply the two numbers together, it equals the same thing all the time. In fact, we could make us a little table. We're not going to worry about the units, but we can make a little table and say, all right, let's just suppose that, say, the pressure was 2 and the volume was like 20. So then pressure times volume would be 40. Now, every time we do this, the pressure times the volume has to be 40, because that's really what the rule's all about. Pressure times volume equals a constant. All right, well, let's take our pressure here and double it up to 4. Okay, 4 times what is 40? 10. Let's double it again. Make it an 8. Okay, 8 times what is going to be 40? 5. In fact, we could even go all the way up to 40. What would the volume have to be to still equal 1? Now note the pattern. As this one kept going up, this one kept going down. And you could go in the opposite direction. If I had started here and made the volume go up, you would have seen the pressure go down. This is what we call an inverse relationship. And that's what our graph shows. As the pressure increased, the volume came down. And so it makes this kind of curve at a constant temperature. If I had a slightly higher temperature, I would get a curve like this, but it would be shifted a little bit because it would be at a different temperature. But they would all have that kind of shape to them. Furthermore, notice this aspect of the pattern. This one, when I doubled, got cut in half for the other one. If I go times 4, 2 times 4 gets to 8. Well, notice 20 divided by 4 brought me down to the 5. So not only do they go in opposite directions, but they have the same factor involved. In other words, multiplying by 2, divide by 2. Multiply by 4, divide by 4. This is what an inverse relationship. Inverse because one went up as the other went down. Basically, we're going to solve problems using this equation, P1V1 equals P2V2, pressure 1, volume 1, the beginning state, equals pressure 2, volume 2, the end state after we changed one of the two, the pressure or the volume. They're going to tell us 3 of the numbers. We plug them in, we solve for the one that's missing. That's how we solve these. So, first off, a balloon contains 30 liters. Is that a P or a V? It's a V. It's a volume. Liters means volume. So there was my initial volume at that pressure. And then my pressure got changed to 25 kPa over there. I want to find out the new volume. So I set up P1V1 equals P2V2. When you do this unit, every single problem, you're going to write down the equation. Because depending on the gas law we're using, it'll be a different equation. So you have to write this down first. Now I'm going to plug in my numbers. All right, 30 liters and 100 kPa on the one side, and the other side a new volume that I don't know and a 25 kPa. Now, how do I solve this? Well, I want to find out V2. I got to get rid of the 25 kPa, so I'm going to divide both sides by the 25 kPa. Note that, over here those are gone, they cancel out, and over here the kPa parts will cancel out, and it'll just leave me liters, the unit for volume. Well, what's 100 divided by 25? 4. 4 times 30. So my new volume is 120 liters. And of course, 30 times 4 gave me the 120, where the pressure went from 100 divided by 4 down to the 25. All right, let's look at a second one. Okay, nitrous oxide is used as an anesthetic, kind of stuff puts you to sleep during surgery. The pressure on 2.5 liters of N2O changes from 120 kPa down to 40 kPa. Again, temperature does not change. For this law to be true, temperature can't change. What will be the new volume? So it's very similar to the problem above. So start off P1 V1, P2 V2. Okay, what's the first pressure? (120 kPa). Now please note, because sometimes students will do this by accident, it says the pressure on 2.5 liters. That's not a pressure. That's a volume. The pressure is over here. And if it goes from this to that, the word to tells you that was the 1, this was the 2. All right, so my first pressure, 120, now times the 2.5 liters, has to equal new pressure, 40 kPa, and again, times the volume I don't know. We solve. Divide both sides by the 40 kPa. And please, folks, notice every single time I write a number, I am writing its units. 40 kPa over there, cancel out. Over here, 120 over 40 is 3. 3 times 2.5, 7.5 liters. 3 times the 2.5 gives us 7.5 for our new volume. 120 divided by 3 gave us the 40. 2.5 times 3 gave me the 7.5. That's the whole idea behind the inverse relationship. That's why the curve looks the way it does. Now, it's not always pressure that changes. Sometimes it's volume that changes. It's okay. They're going to give us 3 of the 4 numbers. So, P1 V1 equals P2 V2. Go ahead and plug them in. P1, 204 kPa. My V1, 4 liters. P2, don't know it. And my final volume, 12 liters. Find P2. So, divide that one by 12. Divide that one by 12 so that the liter parts are gone. 4 over 12 is 1/3. So it's 204 divided by 3. Ends up 68. I might mention that, if you're looking at this later, make sure that you can get the right answers with your calculator when you're doing it yourself. Now, problem 4. First thought you might have in problem 4 is, I don't see any numbers. What am I supposed to do? How can I solve it? Okay? Well, basically, we're going to make them up. Problem says the volume of a gas is cut in half. Okay? So, let's say that V1 was, hey, like the previous problem, 4 liters. All right? Now we're going to cut it in half. So V2 is 2 liters. And I don't care. You could pick anything. You could have picked 40 and 20, 10 and 5. What matters is you followed what the word said. I cut it in half. All right? It doesn't say anything about the pressure. Okay? What is the pressure? Well, let's just make it easy. We're going to just say that the P1, the first pressure, is 100 kPa. Just nice round number. Okay? Now let's solve. P1, V1. P2, V2. Plug our numbers in. Okay? 100 kPa times 4 liters has to be P2 times 2 liters. Now solve for the new pressure. Okay? Divide by 2 liters. Divide by 2 liters. What's 4 over 2? 2. 2 times 100. 200 kPa is the new pressure. Now, that is not my answer. Okay? Because I don't actually have a pressure. But what does it say? How did the pressure change? Well, I picked 100. It went to 200. So what did it do?
Increased by 100 kPa.
That's one way of looking at it. How about it doubled? Cutting the gas volume in half meant the pressure doubled. And it wouldn't matter what pressure I had picked. If I had picked 10, it would have been 4 over 2 times 10. Would have been 20. It got doubled. If it had been 15, 15 times 2 is 30. It would have doubled. So even without actual numbers, I can tell in this relationship that if I cut the volume in half, the pressure has to double. Well, what about the opposite? What if the volume is doubled? What do you think is going to happen to the pressure? Decrease, just decrease, or by any particular factor? Yeah, in half. Well, let's check. Let's do the same thing we just did. Okay, V1, 4 liters. Now we want to double. V2, 8 liters. And let's go ahead and leave our P1 at 100 again. See, we're setting everything up the same way. So P1, V1, P2, V2. Plug our numbers in. 100 kPa, 4 liters. P2, 8 liters. Divide both sides by the 8 liters. So I got 100 times 4 over 8.
That's a half, so it's 100 divided by 2.
It's 100 divided by 2, which is
50.
50 kPa is the P2. So in this case, when I doubled the volume, what can I say about the pressure? Cut in half, or divide by 2, decrease to 50%, something like that. And so this is doing the math of basically Boyle's law. So any questions on this first law? Now, you might say, well, this was kind of boring. It's really easy and simple, but of course, we're going to keep going, and we'll get more complicated as we go along. We're starting with the simplest one first.